Hello everyone. Welcome to the solution of LeetCode problem 2192, named all ancestors of a node in a directed acyclic graph. In this problem, you are given a positive integer n representing the number of nodes in a directed acyclic graph. Here, the nodes are numbered from 0 to n-1 inclusive. Now, you are also given a two-dimensional integer array h, where edge of I is from I to 2i, denotes that there is a unidirectional edge from to 2 in the graph. Now, we have to return a list of answer, where the answer of I is the list of ancestor of the ith node, stored in ascending order. Now, our node U is an ancestor of the node V if you can reach V via a set of edges. Now here we can see that the node 0, it has two descendants, 4 and 3. Node 3 is the ancestor of or descendant of 0 and 1. Or we can say that 0 and 1 is the ancestor of the node 3. Similarly, for this node 7, its ancestor are 2, 3, 1 and 0, because from 2, 3, 1 and 0, we can reach the node 7. So the sorted order are 0, 1, 2, 3. Now for this node 6, we can reach node 6 from 0, 1, 3, 2 and 4. So all of them is stored in the ancestor list of the node 6. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now, before jumping into the solution, the first intuition comes into our mind that this is a basic graph problem, but in which graph algorithm we should use. This problem can be solved using the DFS and topological sort. Anyways, I am using here the topological sort, and we will implement the Kahn's algorithm to solve this problem. Now here, to understand the algorithm, we have taken the same graph. Now let's see how the topological sorting on the Kahn's algorithm basically works on this graph. Now here, in the Kahn's algorithm, we have to deal with the nodes which has the in degree 0, or we can say that we have to start the traversal of the node which has the in degree of 0. So here, the in degree of 0 will be 0, 1 and 2. So we will start the iteration from the 0, 1 and 2. So we will start the iteration from 0. Now, as currently we are at the node 0, we have to check, does the node 0 has some of the ancestors or not? But as the in degree of 0 is 0, so it does not have any of the ancestor. That means we don't have to put or insert anything into the ancestor array of the index 0. After that, we have to discard the outgoing edges from the node 0. It is the basic of Kahn's algorithm. Now we are at the node 1. It also does not have any of the ancestors, so we don't have to insert anything into the index number of 1. But after that, we have to remove the outgoing edges from 1. Similarly, from the node 2, it does not have any of the ancestors, so we have to discard the outgoing edges from the node 2. Now, node 3 has in degree 0 because all of the 2 edges coming towards 3 is removed. So what are the ancestor of the node 3? It will be 0 and 1. Now we have to remove all of the outgoing edges from the node 3. Now this node 4 does not have any of the incoming edges, so the in degree is 0. So what are the ancestor of the node 4? It is 2 and 0. And the outgoing edge of the 4 should be removed. Now we are at this node 5. It's in degree 0 because the incoming edges is gone. So what are the parent of the node 5? The parent is 3. So we have to insert 3 here. Now as the ancestor of the 3 is 0 and 1, we can say that 0 and 1 will also be the ancestor of the 5. As 3 is the ancestor of 5 and 0 and 1 is the ancestor of 3. So alternatively, we can say that 0 and 1 is ancestor of 5 also. So here, the ancestor of 3, which is 0 and 1, will also insert it into the ancestor list of 5. Now we are at this node 6. It has direct two parents, 3 and 4. So we have to insert 3 and 4 here. Now all of the ancestor of 3 is also ancestor of 6. So we have to put 0 and 1 into the 6. Now all of the ancestor of 4 is also the ancestor of 6. So we have to put 2 here, but 0 is already presented into the list, so we don't have to put 0. Now we are at this node 7. It has direct two parents, 3 and 2. So we have to put 2 and 3 here, and all of the ancestor of 2 and all of the ancestor of 3 is also the ancestor of 7. So 2 does not have any of the ancestor, but 3 has two ancestor, which is 0 and 1. So we can say that as 3 is the ancestor of 2 and 0 and 1 is the ancestor of 3. So alternatively, we can say that 0 and 1 is the ancestor of 7 as well. So we have found this list after completion of the Kahn's algorithm, and we have to simply return it. And basically in this problem, we will use the DFS and we will start the traversal level by level. In the first level, we will visit all of the node which has the in degree 0. In the second iteration, we will also visit all of the node which has the in degree 0. In the third iteration, we will do the same and so on. So here, basically, we will use the BFS algorithm in the basis of in degree to implement or to solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named getAncestors, which has integer n and the list of edges. Now we are taking a in degree array to store the in degree, and we are taking a adjacency list and answer list. And to implement the BFS, we are taking a queue. And to store the answer in a temporary vector, we are using a vector of set. Because set has the unique element, so if we put the ancestor into the vector of set, we will get the unique element and in sorted order, because set stored the element in the sorted order. Now, for each of the edges, we have to increment the in degree, and we have to insert the second element into the adjacency list of first element. Now, for each of the edges, if any of the in degree is 0, we have to insert it into the queue. And while the queue is not empty, that means it is the BFS. We have to store the current element or the front element of the queue into a variable current, and we have to remove it. Now, for each of the child in the adjacency list of the current element, we have to insert the current element into the ancestor of child, and we have to insert all of the ancestor of the current element in the ancestor of child, and we have to decrement the in degree of the child. And if the in degree of child is equal to 0, we have to insert the child into the queue for the next iteration. Now, for each of the nodes, we have to store or convert the set which contains all of the ancestor list into a vector and insert it into the answer of file. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.